Welcome to Zaption Tour 7.3 Multiplication Properties of Exponents. There are 5 boxes. The essential understanding here, you can use the properties of exponents to simplify a power raised to a power or a product raised to a power. So let me give you an example of this right away. It's pretty straightforward. We're going to raise a power to a power property. So we are taking a power that exists and raising it to another power already. So as an example, x squared, this is my power, x squared, and I'm raising it to another power, to the power of 4. So x squared to the 4th. Well, I showed you this in class the other day, but consider this, right? What does it mean to have anything raised to the 4th? Well, it just means to multiply whatever is on the inside of my parentheses by itself 4 times. That's what that means. So if I take this principle and I apply it over here, I would have an x squared times an x squared times an x squared times an x squared. And then we can realize that since we are multiplying each of these bases together, we can simply add up all of the exponents. So this is going to give me x to the 2 plus 2 plus 2 plus 2, which gives me x to the 2, 4, 6, 8, x to the 8th. So we can build off of the fact that we are multiplying exponents, or we multiply bases, we add exponents, but there's obviously a faster way, and many of you already see it. I can get x to the 8th by simply multiplying the powers raised to another power. So that's the property that we have for box number 1, okay? And it says this, let me write it down for you. A to the m or raised to the power of n is equal to a to the m times n. There is our property right there. Box number 2 is an example. We have n to the power of 4 raised to the 7th power. Well, this is going to be n to the 4 times 7, which gives me n to the 28th power. Pretty straightforward for that one, okay? And now here we go. I have x to the 2/3 raised to the 1/2. Well, I still multiply those two together. This would be x to the 2/3 times 1/2, which would give me x to the 2/6, which reduces to x to the 1/3 power. And yes, you can do all of that. Okay, box number 3 is a u-try. I want you to simplify p to the 1/2 raised to the 1/4 power. Hopefully got the right answer, but if not, the answer is this. We're going to take p to the 1/2, and we're going to multiply it by 1/4, and we're going to get p to the 1/8 power. Box number 4, we are raising a product to a power property. So notice in the example that I have set up for you, I have 4x all squared. Well, again, if we just write out what this means 4x times another 4x, right? It's just by itself because there's 2 of them. Well, that gives me 16x to the power of 2. So notice that if I am raising a product, 4x all to the power of 2, each of the terms inside the parentheses, the 4 and the x, both get raised to a power of 2 to give me a value of 16x squared. Okay? So note here, there's a very big difference between 4x quantity squared and just 4x squared. In this example here, the 2 is being raised, or the 4 and the x are both being raised to the power of 2. In this example, only the x is being raised to a power of 2. So the property says something like this. If we have a times b, and we are raising it to an m exponent, then that's going to be a to the m times b to the m. Each of my terms inside of my parentheses gets raised to that exponent. Box number 5, this is our last example. I have n to the 1/2 raised to the 10th, multiplied by 4mn to the negative 2/3, all raised to the 3rd power. Okay, so here's what we're going to do. We're going to raise this power to 1/2 to the 10th, so power to a power, we're going to multiply. So that's going to be n to the half of 10 is 5. And then I'm going to raise each piece inside here to the power of 3. Okay, so n to the 5th, this is going to be 4 to the 3rd, m to the 3rd, n to the negative 2/3 times 3. Okay, so let's simplify this part right here, the negative 2/3 times 3. This gives me n to the 5 4 to the third is 4 times 4 is 16 times 4 is another 64, so 64. And then I have m to the third. Now when I raise a power to a power, we multiply the powers together. So 2/3 times 3 is just -2. So n to the -2. Moving along, I can see that I am multiplying n to the fifth times n to the -2. If I am multiplying variables with the same base, I add their exponents. So this is going to give me 64m to the third. N to the 5 minus 3 is also to the third. And the answer, 64m to the third, n to the third. I hope that part made sense to you.